So far with my water bottle experiments we've been using a parachute for recovery, which has worked out quite well. But today we're going to do something a bit different. We're going to use a glider to recover the rocket.
5, 3, 2, 1, 0, and liftoff of Space Shuttle Atlantis.
The most famous rocket glider system must be the Space Shuttle. It flew 135 missions from 1981 to 2011, most famously launching the Hubble Space Telescope. It used 3 Rocketdyne RS-25 liquid hydrogen-oxygen engines, which I think technically makes it a water rocket. It then glided back without propulsion to land on a conventional runway. It was often said that the shuttle flew like a brick, which may be another characteristic in common with our vehicle. The concept hasn't gone away. This is the Sierra Nevada Dream Chaser, which is going to be resupplying the ISS. With our vehicle, we want to make sure that we get stable flight, so we always point forwards and don't tumble out of control. To get stability, we want the vehicle to weathercock, like a weather vane, so it always points into the wind. To do this, we must make sure that the centre of pressure is behind the centre of gravity. The centre of gravity is the balance point of the vehicle, and the centre of pressure is the average position where aerodynamic forces act on the vehicle. Determining the centre of pressure can be quite hard, but luckily we can test stability directly in a wind tunnel. A cheaper version can be made by tying string to the centre of gravity and whirling the vehicle above our head. If it doesn't tumble out of control, we have stable flight. We also tested the flight characteristics of the glider on its own many times, just to be sure. We filled the pressure chamber with about 400 millilitres of water, which is about normal, and then we pressurised to about 80 psi. This is a bit less than our normal 100 psi, but it was quite busy and windy in the park, so we didn't want to push it.
Oh, wrong way. Oh, you can't see it.
We got some good height and only broke the tail and fin, which were already damaged before we launched, so I'm calling this a success. On a subsequent flight without strong wind, we noticed that the vehicle always fell over backwards, most likely due to weight and lift from the wings, so the design will need some changes to account for this in the future.